agenda today is just to give you an overview of NZ current regulations. I'll talk about smart homes a quick bit at the moment and at the end, sorry, and future prospects, and just give you an overview of some of the projects we're involved in. So something stopped there. I'll have to flick on. I'm not sure what happened there, sorry. So just a quick overview. These are our current levels of CO2 emissions, and we've got 18 of the warmest years have been in the last 20 years. So buildings are part of that solution, and we need to mitigate and be able to manage kind of the warming climate and reduce our CO2 emissions. So basically how it all started with the Energy Performance of Buildings Directive was in 1997. The Kyoto Agreement came through there, and then we had the Energy Performance of Buildings Directive. It was recast. It's actually being reviewed at the moment. I might throw a controversial one in there that I've been in discussion with some of the people that are looking at European level, and then nearly in the future is probably going to become net zero over an annual balance of a year. So this is the Irish Climate Action Plan, and the two of the big kind of pop outs for me and for us at the moment in buildings is 500,000 retrofits have to be done to a B2 BR. A lot of them are being improved. We're hearing better now at the moment than a B2, and install 680,000 heat pumps and 400,000 into existing buildings. So big targets there, big kind of requirements for us in the future. So the construction and building environment account for 37% currently of Ireland's emissions, heat and cooling, lighting 23%, and the embodied energy and the carbon emissions due to the life cycle analysis we'll talk about in, I think it's webinar 8, is 14% of our total emissions. So the nearly energy buildings from the EPD, Energy Performance of Buildings Directive, is high energy performance, low amount of energy required, and covered significantly locally or close by or nationally by renewable sources. So they were updated in the 2019 Part L Conservation of Fuel Directives, and updated again in the 2021. Not a huge amount in 2021, but it's still a good document to read. It applies to new dwellings, and it applies to existing dwellings where there's a major innovation, which is responsible for over a quarter of the building envelope surfaces. And there's ways of calculating that and looking at that in Part L. Won't go into it in too depth. So to certify the building and see that you're in compliance, we use the dwelling assessment energy assessment procedure, which is the DEEP, which is the BR assessor has to model and comply with it. So that shows that an A1 is less than 25 kilowatt hours per square meter per year, and a poorly operating house is 450 kilowatts per square meter per year, and that's quite a high level. And then if you look on the right hand side, it shows the watts per square meter requirement of a house per year. We'll be sharing this at the end, so if I go a bit fast and you don't manage to take everything in, we'll be sharing these presentations. So currently it's 70% of an improvement on a dwelling from 2005. The EPC, the energy performance coefficient, and the carbon performance coefficients have improved by 70% and actually 65%. The renewable energy ratio is 20.2, which is 20% required. So how we, as I already mentioned, how we check that that's compliant with the building regulations is through the DEEP. And there's a big thing that I've noticed in modeling. If you use acceptable construction details, your psi value for your building, for your thermal bridging goes down quite significantly, and can bring up gets a better performing building, but it can bring up your BR rating too. So this is a nice little photo that we took when we were in Mount Lucas, which gives a kind of a bit of an overview. So it shows continuous insulation, airtight vapor control, low thermal bridging, reduce your psi values, high performance windows, mechanical ventilation where required. That's if you're below 3 cubic meters per square meter per hour. which we're finding a lot of buildings are getting that without even kind of trying too hard to get it. They're actually to get, because the construction kind of training of NZEB is proving and showing that it's better performing buildings and better delivered buildings. High efficiency heating, that's like looking at your heating system, your thermal losses, insulation in your heating mechanical ventilation systems, and also renewable energy. Excuse me. So heat losses and gains, as the picture on the right hand side, is conduction, convection, and radiation, which is different kind of flows. I'll let you read that in the future. So the heat losses are during the heating season there on the top, and the heat gains, which we're noticing nowadays, is overheating is becoming a thing in buildings across Northern Europe now, where it wasn't really a thing before. So they're the gains that can come in through your buildings as well. So I do a quick intro to U values. On the left hand side is U value calculator. So how you calculate is you use all the different elements that make up your fabric. You calculate them across the and they give you an R value and divide that by 1, and that gives you a U value. So I've just given a quick picture of a U value calculator there that I use. That's quite good, and it gives a nice 4-page little outline of the PDF of your building fabric of that particular U value. So the U values can be found on page 47 of Part L of a building regulation, TGD, and also all manufacturers' websites will give you the thermal conductivity. Sorry, not U values. I mean thermal conductivity. That's the conductivity of the material. That's the insulation. And there's a nice little quick calculation that somebody else gave me before. If you're ever doing a design stage or you want to figure out what thickness of a particular material will give you quickly, it's only using the insulation, not the whole building makeup. So it'll give you a bit of an idea what your U value will be there on the left hand side. So if you divide your thermal conductivity by the thickness of the material, it will give you the U value. And then also, if you want to do the kind of revert that a little bit, find out how thick, what kind of a thickness of material you'll need. If you divide the thermal conductivity by the U value, it will give you the thickness that in and around the thickness you require. But you need to work out the whole. That's just a kind of a quick overview, and then you have to work out the whole build, the makeup of the whole fabric. So these are kind of nice little U value calculators that I use. The one on the top is the BRE, the Building Research Establishment. The one on the right hand side is Ubicus, and the one on the bottom there is a sheet from the PHPP. They're all certified to the standard for thermal conductivity, and I checked them all across the board, and they all work very well. So if you like the internet one, which is Ubicus, the sheet or the tool, you can use whichever one you like there. So thermal bridging also is another big thing, as I mentioned, in the heat loss and heat gains, and there where the plane elements join, so your U values and your fabrics join up with each other, and that can be quite a crucial area. So as you can see here from the picture on the right hand side, where the thermal bridge and the insulation isn't being kind of installed as correctly and as well as it could be, there's a heat loss there, and that could cause interstitial condensation. It could cause heat loss, it could cause mold, and it could cause condensation on the internal walls. So it could cause issues. And also when we find in that, like mold, and can cause spores to be floating around in houses, and that can affect people's health. So that's another thing that it's not just the building heat loss, it's the internal air quality and lots of other things that are up there for it. So here's the air tightness, quick review of it, and also that's the heating year, the time of the heat year when it's cooler outside. Your warm air is wanting to go to the colder area, but also if you revert that for the summer season, that's where the warm air can possibly come in and cause your house to overheat as well. In certain instances, they're finding now excuse me, a bit of it's called the heat island effect, that in cities and towns, because the concrete and a lot of the kind of fabric and the roads and all that are soaking up heat during the day, at night when people want to try and use their windows for cooling, that the radiation, the heat is radiating back off these elements, and then causing the air to be a bit warmer, and they're not actually managing all the time to be able to cool their buildings. So there's a thing about that and air tightness and maybe cooling requirements in the future, especially in the urban areas. So I'll just go through the U values are here for new build in Ireland. I might be controversial here, but I would not use a 1.4 of a window if I'm putting in a new window. I would use there's windows out there with a standard of 0.85 to 0.7, so and they're about 8 to 10% more expensive than windows of that U value. And doors, you can get doors nowadays that, again, if they're new, to a U value of up to 1, they're composite doors and all that, and they're all certified and that kind of thing. So for retrofitting, these are the U values, and this is if it clicks on that 25% of the surface requirement. But I also, I'm going to go into that in another, so I won't mention it yet. I'd also, if I'm replacing my windows, not doing them up, I would be going for a better U value than that. That's my personal opinion, because the overall energy balance of the year means it stops the heat loss over the winter, but also the good U value and the good G value, the solar gain value on the glass stops overheating as well in certain times of the year. East, the air is not too hot in the morning, so but south all during the day and west during the evening when the air is warmer, the radiation can get into your house is easier. So again, I'm open to any suggestions that might disagree with me on that, but I would go for as high U or a low U value for your windows as possible if you're replacing them. So in architecture, historical and heritage buildings, we have to look at the whole picture. We can't just go in there and kind of, as I joke about, put plastic windows into the Kilkenny Castle or retrofit Dun Aengus with external insulation. We have to look at the picture and the heritage and the culture of things and do what we can. And there's lots of kind of materials out there that work really, really well with kind of older buildings. They're breathable. They've got more kind of heat attenuation. They're able to soak up heat and give it away. And the code of practice there is a very good document to have a read over as well, the SR 54, just to have a look at, because there's a lot of good information in there. There's a lot of reading to be done when you want to get into a lot of this stuff, and I suppose I don't have a TV, so I've done a lot over the years. So the grants available at the moment for major retrofit for dwellings, or there's a one-stop shop which looks at the whole picture and wants to do the whole retrofit in one go. And then there's individual grants, and I suppose this triangle or inverted triangle gives us the climate impact, but all these measures are actually worth doing as well, including the energy storage. I have batteries at home now. My solar PV is producing more electricity than I have. A load on in the house is only 400 watts at the moment, but we're producing about 5 kilowatts, so my battery is charging. And you know, there's these options for renewables where you can heat your water and maybe even turn on your heat pump in the future. This is be the smart buildings. So another thing we're looking at with the Tipperary Energy Agency super homes and the IGBC is to have a building passport. So if you're not able to, if you don't have the facility at the moment to retrofit your building, everything in your building today or this week or this year, that you have an overview and assessment and a passport that shows you all that has all the measures possible in the future. And that means that you might not do something today, insulation or wind or airtight, that you might have to go and change in the future. So it gives an overview and a potential for your building. And we're looking at maybe having, because a logbook for a car is about 1.5 inches thick, is that metric, 1.5 inches, 40 millimeters, 48 millimeters. But sometimes when you get a house handed over to you, you get a key and one sheet of paper. Whereas we always believe that we used to give, when we were installing renewables and we were doing kind of sustainable buildings at the time, we'd always give the homeowner a day with probably the plumber, the installer, even the electrician, and someone that we'd all go through and show them how the building worked and how all the heating systems. Because when we've got smart buildings, the people that are living in the occupants need to know how these buildings work and how to kind of adjust different bits and pieces for heating. Because I always believe that it takes at least a year or two heating seasons to figure out how your heating system is working, because you know certain things work differently in different kind of circumstances. So I used, Stevie came up with this cool car analogy, and a car analogy for buildings is a good one. So basically, the Golf is a B2, the Formula One car is an A1, and the lorry is a G. And it basically means lower the load, higher, make your engine size would be your heating system more efficient, and high the faster you get to heating or cooling or whatever you need, the better. So that's a kind of a nice analogy that Stevie came up with. Thumbs up there. So we modeled the BER then for just to check on today's energy prices, and we looked at oil, natural gas, air source, ground source, wood pellet, and wood chip, and we saw that this is the cost per year that we have. So you can see when we get more into the more sustainable and kind of energy efficient kind of heating systems, the cost is less. I just show you there on the wood pellet. I have a wood pellet stove that heats my underfloor, that does my space heating as well. It's cost me €1,200. I love data in the last 4 heating seasons. So it's basically cost me 300 quid a year to heat my house at the moment. And our heating system is, it's not quite to passive standard. I failed a bit on the air tightness test, but we've had our heating off since March, and we probably won't in the last 3 years. We haven't turned it on before at the end of kind of towards the end of October. So I modeled, I just did a quick thing in the BER deep there just to show you what how you can get even from an A3, which is energy is it's 58 kilowatts per square meter per year. That was a quite high efficiency and good planes and a low heat loss indicator. And I threw on 5 kilowatts of PV as into the renewable tab, which generates 475, and that then turned the house into an A1 minus energy. So it's actually negative energy use and negative CO2 emissions. Just show you there as a kind of that renewables are a good option in certain circumstances. So I suppose smart homes with the future will be where everything talks to each other. Your solar system will talk to the house, and if it could heat the water or charge your car, if that's what's required, or charge your battery that you might have in stage. In the future, if you've got too much solar, even in the winter, it might turn your heat pump on. It could go to sell to the grid if somebody down the road needs some. You can donate to the grid. We're doing a pilot scheme with the IERC and Glasgow Energy at the moment, to where I could virtually donate electricity, because I think my thing is going to, I spilled 1.7 megawatts, 1700 kilowatts to the grid in the last about 150 days, but the 200 quid, 300 quid extra a year, I'm not overly pushed on that. Probably spend more than that on coffee. So I wouldn't mind donating at fuel poor houses virtually in other parts of the country. So if you can instruct the utility to take it off, it can be done in the future. We're not there yet. And obviously the rainwater harvesting is another very big thing that we installed in a lot of houses in the past, because we're looking at the loads. The reservoir levels are getting down, and we're using, I've been involved with Trinity College guys with a couple of hydro projects, and we looked at rainwater harvesting and stuff like that as well. And we only need about 1-2% of our water needs to be potable drinking quality. So the other nut said we'll just call it 90% can be our rainwater, and it just, you know, it can do the flush the toilet. We can wash in it. We can wash our clothes. We can even use it in the dishwashers and all that. And you can actually get a filtering and upgrade system where the rainwater it's certified to potable quality. In some of the feedback we got from houses that we did install it was that you use less detergent because the water is softer. So you're using less washing up liquid at the sink. You're also using less detergent for washing your clothes. And some of the feedback we've got with that it's nicer on the skin because the water is less hard, and it's nicer on the hair. So the feedback was very beneficial from the rainwater harvesting. I think in the future that will become it is coming more into the deep assessment, and I think it will be more in the future, because the guys from Trinity kind of made a very nice point once. Why are we flushing food down the toilet? Because it's a food grade substance, potable water. Stop talking about that now. So the other thing then is modern methods for construction. I'm in touch with PJ Rodden on certain things there, and you know where offsite construction is more efficient, it's faster. it certifies a lot of the different parts of the fabric, and it can speed up and deliver faster, better houses. And it's got a lower embodied carbon, lower waste, and lower things. We also have on the left hand side here is a project called BIMZig we're doing, which is BIM and NZEB all mixed up together. If anybody's interested, you take that, you can go and log into that site. We've got 12 learning units there that are very, very informative, that we worked on a good few European partners on it, and all the information is free. The website's open for the next 2 years. All the information is free on there, PowerPoints, PDFs, everything. It's all free to load. So just a quick overview now. I think I'm 23 minutes in over time. So overview of some of our other projects. Our green public procurement one is where we're creating training. Stephanie's creating training for an online training course, which we're going to be delivering in September. Anybody that it's aimed at kind of local authorities. So anybody there today that's interested in that, work for a local authority, give us a shout, and we'll put you in touch with the project lead. So this one, BuzzGo Circular, is one where we're looking at blended measures to get energy demand and training for NZEB across the whole sector. This Build Up Skills app also is a thing that we're working on. We work with the SEI, IGBC, and when it was two before I came along. And it's a place where you'll be able to go in the future, look for training for your particular role. So if you're a carpenter, if you're a professional, a kind of a beaker, a certifier, an architect or whatever, and it'll give you trainings from NZEB kind of at the ETVs, which I'll be talking about in a minute, and also the into degrees, and masters and PhDs, and so it gives you the whole overview from maybe a day's training to 5 years training. We're looking at possibly in the future that I could certify that I've done and show that I've done these courses. And if somebody was looking for somebody that has these skills, they can go onto this app in the future and find someone if they've shared their GDPR and their information, and go and find a person if they're looking maybe for employment or whatever. So we're kind of jiggling with that with Jan in Holland at the moment, who's our lead on the Build Up Skills app. So next then is the training for the NZEB courses, which at the moment there's 3 in the country, WWETB, Mount Lucas and Limerick. Two of the experts are on this call at the moment, Barry and Bev, my stuff lads. They've taught me lots of stuff in the future. This is the NZEB training courses that you can do at the ETBs at the moment, and there's the way to find it. That picture on the right is a display kind of rig in Waterford that has an airtight room here, and outside it's got the different envelope build-ups. Around the other side it's got some other external insulation, wood-based, EPS, polyiso. It's got internally, then it's got the air tightness. It's got some defects, and this yoke here is an air tightness fan. So when Barry turns that on, you can see all the defects. You can open the windows, you can see where the air is coming in, you can see defects that cut hole in the air tightness tape, and show how to assess where mistakes may have been made, and also repair them very easily. Because if you can find an air tightness leak before the building fabric has been all closed up, it's very easy to repair. And then they have these pendulum fans that are kind of they work, 2 of them work together, as in if you have a retrofit and you can't put all the piping in for it, but your air tightness requires mechanical ventilation. And if it's very difficult to put all the piping and ductwork, and these yokes work, and one takes out the air, it goes through a ceramic core that takes the heat, recovers the heat, and the other one takes in the air, and then they work backwards. So they work really, really well together, and there will be people talking ventilation in the future. And then we have our DASB Digital Academy for the Sustainable Built Environment, and these courses are what we're developing now at the moment, and we're teaching. There's new ones coming on online. I think I'm supposed to be helping out with a bit of teaching in the future. So if you want to contact anyone to get some more information about that, Liz O'Brien is the DASB manager. And then we have the Buzzgo Circular, which another friend, Martin, is in charge, is lead on in Ireland, and it's basically about multifunctional green roofs and how they work together. So we're increasing market demand for circularity skills, so everything stays in the circular economy. I think that's number 8. Develop training courses, bringing more women and youth into the circular economy, because at the moment, into the construction profession, and add to the circular skill, because at the moment 12 to 16% is women in the construction sector. We need to increase that, because they find more gender balance in projects and on sites, and even in design stage, people work together and the delivery and the outcomes are better. So that picture at the top is me, young fella, doing the virtual reality training with Barry at WWETB, and we're bringing down another load of transition year students as part of this project to next Monday to do virtual reality training. So it's virtual reality in retrofitting, so you get to go put in a window, insulate it around it, do air tightness, do insulate an attic, and all these types of things. So it gives people an overview and an introduction, and then you can go and look at the actual rig, like the picture I showed you there. And there below there is a sustainable kind of it's kind of a green product. It's wood-based and sand-based insulation with lime-based cork insulating plaster on the back and lime-based plaster on the front. So it's a breathable. So that would be working very well in a traditional and a kind of a culturally kind of older type of building. Thanks for listening. Tomorrow, April will probably be a bit kind of faster than me and get a bit more overview. And if you need to talk to me, there's my email there. I'm going to hand you back to Stevie now, because he's going to take care of the questions. I'll stop sharing. Thanks a million. Sorry, that was supposed to be 15 minutes.
There's no bother at all, Benny. And just unfortunately, we don't have any more time. We only have about a minute left on. So we're going to have to cut it short, but there's been 3 questions that have come up, and we'll make sure that we'll email back the answers. Probably the best thing to do. So as Benny said, that tomorrow there'll be another webinar